In today's lesson, we're going to be looking at the compound angle formula for your tan function. So it turns out that the tan of x minus y is defined to be tan x minus tan y over 1 plus tan x tan y. Now we had just talked about the compound angle formula for cos and sine. If you missed that lesson, I'll link that in the top right hand corner. To see a proof of why the tan of x minus y is in fact equal to this here, let's take a look at the following. Now we know that the tan of any angle is equal to sine of the angle over cos of the angle. So now again, we've already proven the compound angle formulas for sine and cos here. So I'm going to go ahead and apply those. Now what I'm going to do is I'm going to multiply the top and bottom of this expression by 1 over the cos of x, cos of y. We're going to do that in the top and bottom here. So essentially, you're still just multiplying across by 1. Now you notice here, we're going to take the 1 over cos x, cos y. That's going to get applied to each of these terms on the top and each of these terms in the bottom. Doing so, we get, so distributing this in the top and bottom here, we have some cancellation here. You can see here the cos y's will cancel, and here we have the cos x's will cancel, and here the cos x's cancel, and the cos y's cancel, and in the final term we have no cancellation. So this simplifies to become here, you'll notice we have sine x over cos of x becomes tan of x, then we have sine of y over cos of y becomes minus tan of y divided by, everything cancels in that term there, so we get 1 plus, this ends up being tan x times tan y. So therefore, the tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. And there's our proof for compound angle formula for tan of x minus y. Let's take a look how we find the compound angle formula of tan of x plus y. So to show the tan of x plus y is equal to the following, we do a similar trick as we did in a previous lesson. I know the tan of x plus y can be expressed as the tan of x minus negative y. And now using our compound angle formula for x minus y for tan, this would end up being the tan of x minus the tan of negative y over 1 plus the tan of x times the tan of negative y. Now your tan function, if you recall, is an odd function, and because of that, because your tan function is an odd function, the minus sign can come out here, and this ends up being the tan of x plus the tan of y, all divided by 1 minus tan x tan y. And again, that minus sign here came about from the fact that tan is an odd function, so that minus sign can be brought out of the expression, and we have our minus sign here. So therefore, the tan of x plus y is equal to tan x plus tan y over 1 minus tan x tan y, as we wanted to prove above. So now we have our compound angle forms for your tan function, both for x minus y and x plus y. Let's take a look at some application questions of these. So to find the exact value of the tan of 15 degrees here, what we can do here is, I know that the tan of 15 degrees is in fact equal to the tan of 45 degrees minus 30 degrees. So now here I can use my tan of x minus y formula, so this will become the tan of 45 degrees minus the tan of 30 degrees, all divided by 1 plus the tan of 45 degrees, tan of 30 degrees. Now, if we go to our unit circle here and we take a look at what exactly is the tan of 45 degrees, if you remember here at the 45 degree measure, when theta was equal to 45 degrees, this was 1 over root 2, 1 over root 2. So since your tan function is sine over cos, this is going to end up being 1. So the tan of 45 degrees here will yield a value of 1. And if we look at a measure of 30 degrees, so let's say we're over here, and we look at 30 degrees here, you'll see that the point on 30 degrees, this was root 3 over 2.5, and you'll notice that the tan of 30 degrees is going to be equal to 1/2 over root 3 over 2, and that ends up being 1 over root 3. So substituting this all in here, we get 1 minus 1 over root 3 divided by 1 plus 1 times 1 over root 3. And cleaning this up here, we get root 3 minus 1 over root 3 divided by root 3 plus 1 over root 3. You'll see here we get cancellation in the root 3's here, and our final answer becomes root 3 minus 1 over root 3 plus 1. And there, that gives us an exact value of the tan of 15 degrees. Let's take a look at another example. In the next example here, we want to simplify the following expression. The idea here is that this expression resembles our tan of x plus y formula. You'll notice here you have the tan of 20 degrees plus the tan of 32, all divided by 1 minus tan 20, tan 32. So in this situation here, this is equivalent to being the tan of 20 degrees plus 32 degrees. So this ends up being the tan of 52 degrees. Now, 52 degrees is not one of our special 16 points on a unit circle. So we're going to leave the answer as this. So simplifying this, this is tan of 52 degrees. Let's take a look at another example. Taking a look at our next example here, we now know the sine of x is 3/5, sine of y is 4/5, and x and y are in that first quadrant. And what we want to find here is you want to find what is the tan of 2x plus y. Well, first of all, the tan of 2x plus y is equal to the following. Tan of 2x plus tan of y over 1 minus tan of 2x, tan of y. Now, if we take a look here, let's go to our unit circle here. And you'll notice here, if I'm focusing on our measure of y here, I know that for a given triangle in that first quadrant, I know the opposite is labeled as a 4, and the hypotenuse is going to be 5. So therefore, that leftover leg is 3. This is a 3, 4, 5 triangle. So right away, we know the tan of y is equal to opposite over adjacent. That's going to be 4/3. So I know the tan of y value is 4/3. So looking at our unit circle here, having a measure of x, again, that acute triangle in that quadrant, I end up getting the opposite is 3, 5, and this ends up being 4 down here. So now we know that the tan of x, in this case, is going to be opposite over adjacent. You're going to get 3/4. So I've got my tan of y value. I need to find my tan of 2x value. So what is the tan of 2x? Well, the tan of 2x is equal to the tan of x plus x, which using our x plus y formula, we know that's going to break down into become the tan of x plus the tan of x over 1 minus tan of x times tan of x. Since we know that the tan of x is 3/4, this will end up being 3/4 plus 3/4 over 1 minus 3/4 times 3/4. Continuing this on here, this ends up being 6/4 over 1 minus 9 over 16, which is 6 over 4 over 7 over 16. And again, we multiply by the flip. This becomes 6 over 4 times 16 over 7. And that'll reduce to become a 4. And we end up getting 24 over 7 as our value for the tan of 2x. So therefore, we can go ahead and substitute this all in. So follow our arrow down here. Therefore, the tan of 2x plus y is going to equal, continuing on here, this ends up, we need to get a common denominator here. So we're going to put this all together. We end up getting 100 over 21 divided by 1 minus 96 over 21. And this ends up simplifying to become 100 over 21 divided by negative 75 over 21. The 21s will cancel here. We get 100 over negative 75, which ends up being negative 4/3. So therefore, the tan of 2x plus y becomes negative 4 over 3. All right, that concludes today's lesson on compound angle formulas for the tan function. Thank you.